Today we are taking a look at how to find the average value of a function in calculus. So let's just start with what we should know by this point, and that would be finding the area under a curve, or between the curve and the x-axis. So if I were to ask you to write an expression for the area of this shaded region, which is the area between f of x and the x-axis between 1 and 5, then hopefully you could look at that and say that would be the definite integral from 1 to 5 of f of x dx. And hopefully that'd be a pretty straightforward thing. That's that area. Great. And now I would just ask you to think about this, just so the formula makes sense, because there's so many formulas you got to remember in calculus, and the more they make sense, the easier it is to keep them straight. That it's basically rectangular, this region, on three sides, right? The bottom's always going to be flat, the sides are always going to be perfectly vertical, and it's just that the top is like a curve. If you were to take a rectangle and do its area divided by its base, what would that give you? And hopefully you're thinking to yourself, that would give you the height. And that's the same thing that's going on here, really. If I were to take this area that we just found and divide it by the base, and the base would be this distance between 1 and 5, which would be 4, that would give you the height of a rectangle that had that area. That would give you some height, which would be something like this. It would give you that single height. Probably drew it a little bit too high. But what that height, what that represents is the average y value for that curve over that interval. It's that single y value that's kind of representing the curve might be going up or down, back up, whatever, but that one height, that one y value is the average value of the curve. So I just want you to think about that when you're thinking of this formula. When you're trying to find the average value, you're just doing the area divided by the base, and that's the height, which is the y value. Okay, and how do you do that? In calculus, that's going to be finding the area over the interval a to b, would be definite integral from a to b of f of x dx, and then we would want to divide it by the base. Now, because it can look a little ugly to put that in the top of a fraction, a lot of times you'll write it out in front. Instead of putting over that base, you're going to put 1 over, and the base would always be found by doing b minus a, the difference between those two. So that right there is the formula for average value. 1 over b minus a times the definite integral from a to b. But it's just area divided by base. Okay, so let's try a few problems here. I've got a variety. Hopefully, just shows you all the little subtleties and nuances of it. So this first one, find the average value of f of x equals 4 sine of 2x over the intervals 0 to 3. And I provided the graph just to, it never hurts to review these graphs. The 4 is the altitude of this sinusoidal graph. 2 in there is going to make the period be pi, so it's going through some things, twice as fast. The frequency is 2. And so here we go. Let's actually dive in here. The average value is going to equal 1 over pi over 3 minus 0. I mean, sure, you didn't have to write the minus 0. Multiplied to the definite integral from 0 to pi over 3 of this function, which is 4 sine of 2x dx. And of course, you want to be in that good habit of always writing your differential on the ends of your integrals. Okay, so this fraction 1 over pi over 3 minus 0 is obviously just 1 over pi over 3, and 1 over pi over 3 is 3 over pi. But now we're going to be multiplying that to the value of this definite integral here. So here's where we're going to have to actually integrate, right? What's the antiderivative of 4 sine of 2x? The antiderivative of sine is negative cosine of whatever that inner quantity is, which is 2x. And since that's a 4 out in front, but we've got a 2 on the inside, which would, a 2x, which would cause a little chain rule. So to undo that, we have to, instead of multiplying by 2, which the chain rule would require, we're going to divide by 2. So that coefficient of 4 is going to be 4 divided by 2, which is 2. And hopefully by this point you're able to handle that kind of a thing here. I didn't put any crazy complicated integration in here, thinking this might be at the beginning of the integration unit. But if that was a little weird for you, just think about if you took this derivative, right? Derivative of negative 2 cosine would be positive, or excuse me, would be positive 2 sine of 2x, but then you'd have to multiply by 2 because of that chain rule, making that be a 4 there. Okay, so there's our antiderivative. And now this is the fundamental theorem of calculus, right? Is substituting those limits of integration in. So pi over 3 goes in first, the upper limit. So you would get negative 2 cosine of 2 times that pi over 3, which would be 2 pi over 3. You might start to say that looks familiar. Minus negative 2, so minus negative 2 is going to become plus 2 cosine of 2 times 0, or 0. And now we've got some values that should look pretty familiar. So this is 3 over pi, and on the inside here, cosine of 2 pi over 3, cosine of 2 pi over 3, that's going to be 1/2, but 2 pi over 3 is in quadrant 2, where cosine is negative, so that's going to be negative 1/2 plus 2, and the cosine of 0, hopefully you're thinking of that position on the unit circle where the x coordinate is 1, so the cosine is 1, cosine of 0. And now here you go, you have some nice numbers there on the inside actually. So you have 3 over pi. On the inside, negative 2 times negative 1/2 is positive 1 plus 2. And of course, that's 3. And 3 times 3 over pi is going to be 9 over pi. That is the average value. So just for a little representation here, this 3 on the inside, that was the area between 0 and pi over 3, expressed as a decimal there. So that was that area, was 3 on the dot. But then when you're dividing it by pi over 3 or multiplying by 3 over pi, that's giving you what the average y value is. And you can see the highest y value is 4, the lowest is 0, but the average one over that interval is 9 divided by pi, which would be about 2 point something or other, a little bit less than 3, probably 2.8 or so. And that would make sense to be around there. That's the average y value, taking all those y values into consideration. That would be about it. Okay, so there's one example there, and a little brush up on trig and unit circles, and antiderivatives, chain rules. And now how about a calculator problem? Use a calculator to find the average value of this function g of x equals 1 plus e to the 0.5 x cubed minus 2x. Notice that's a pretty funky looking graph there, again just for visualization. And although we're going to use a calculator, hopefully you're in the habit to always express on paper what you're doing with your calculator. The calculator can do the work, but you've got to communicate to the AP graders. So this here, I meant to say over the interval of -2 to 1. I should have said that, but whatever, I'm adding it right now. Okay, yes, I could have made up any interval there, but -2 to 1, and you can see the y values get up there near to 6. Right here, they're around 1, so you would think the average y value is going to be somewhere in between here, maybe around 3 or 4. So we are going to, again, you're going to find the area, which will be the definite integral, and divide by the base. So that's 1 over 1 minus -2 times that definite integral from -2 to 1 of And you can, even if you're using your calculator or not, you can express with shorthand function notation, g of x dx. You don't have to write the full function in there. So that's going to be 1/3 times the definite integral from -2 to 1 of g of x dx. And now let's bring in the calculator here. So here we are. So a little brush up on maybe some shortcuts here. How do you make a fraction? That would be in the F1 shortcut menu, alpha y equals. Of course, you can just do 1 divided by 3, but sometimes it's nice to brush up on where these little things are. 1/3 times, and the definite integral symbol is math 9. So math, and you can scroll down or just hit math 9. And we're going from -2, it's the lower limit, to 1 of, and what are we integrating? This is where you got to type the equation, 1 plus e to the 0.5 x to the third minus 2x, that's all in the exponent there, and with respect to x there on the end. Now you hit enter and you let the calculator go to work, and notice it gives you about 3.154, which we said, hey, that this answer should be around in this ballpark, 3.154. Notice I also could have done this kind of thing, 1 divided by 3 times math 9 from -2 to 1. And if you already had it in y equals, like sometimes on an FRQ, you'll graph a problem to do parts A or B. But if you already have it in y1 or one of the other graphs in the inventory there, you can simply put y1 here. So you can alpha trace, the F4 menu brings up the inventory there, and you can simply put y1, and that will do the same thing. So those little shortcuts are handy to be comfortable with. Okay, now let's go on the last problem here, just so we see a full variety here. We did one completely by hand, and now we did one with a calculator. Now we're going to do one by hand from a graph. So there's no equation, but we're asked for the same concept though, average value of f of x on the interval -7 to 5. So average value would be 1 over 5 minus -7. And of course, if you can just do that in your head, that's fine. Multiplied to the definite integral from -7 to 5 of f of x dx. Right, so we're going to be getting 1/12. That's the whole base, the whole length of the interval from -7 all the way to 5, multiplied to this area. And the area, quote unquote area might be negative here if it's mostly below the x-axis, which a lot of this is, but not necessarily all of it, most of it. So let's find that value now here using the graph. So we're starting at -7, we're going all the way to 5. So this first portion right here is what we're going to find, and that's above the x-axis, so that will be we'll assign a positive value to that area. But then between -5 and 1, you have a big triangle between the graph and the x-axis. It's below the x-axis, so we're going to assign a negative value to its area, and then we're back above the x-axis with a semicircle, so we'll find that area and give it a positive value. So this is just a review of those kinds of things as well. So the first area up is this triangle here. That's a 2 by 2 triangle, so 1/2, 2 times 2 is of course 4 divided by 2, or 2. So the area of that is 2. This area of this red triangle that's below the x-axis, that has a base that goes from -5 to +1, so that's a base of 6, and its altitude is that distance right there. So I didn't really, should be -1 straight down to 4. That's an altitude of 4. So the area is going to be 1/2 base 6 altitude of 4, or an area of 12. But again, it's below the x-axis, so I'm going to assign a negative value to it. And this semicircle, that's going to be half of the area of a circle, or half pi r squared. What is the radius? It's the diameter goes from 1 to 5, so that radius is 2. Or you can draw the radius up and see it in that direction. So that'll be 1/2 of 2 squared, which is 4 pi, which will be 2 pi. And again, that's above the x-axis, so we'll assign a positive value to that. So we have, when all is said and done, we have 2, but then we dip below the x-axis and take away 12 units of area, and then pop back above the x-axis for an area of 2 pi, and we're multiplying the entire value of that by 1/12. So this will be 1/12 of 2 minus 12 is -10. -10 plus 2 pi, we're just going to call that 2 pi minus 10. And you could put that all over 12 if you like. It does reduce by a factor of 2. If you divide all of those terms by 2, you'll have pi minus 5 over 6, or pi over 6 minus 5/6, or something to that effect. But there is our final problem there, kids. So hopefully you saw a variety and got the concept down of what average value is. It's just area divided by base. And you got to brush up in all the ways you can find those definite integrals: calculator, graph, and with the fundamental theorem of calculus. All right, if you have any questions, reach out. Otherwise, keep working hard.